All right, we've now moved on from the core service provider network concepts into a topic that I'm sure you can appreciate the importance of with me, IP addressing, right? I have a smile on my face because over the, 14 years now I've been teaching Cisco classes. I've taught a lot of CCNA classes, hundreds of them. And I usually get a question, at some point in those class from a student saying, okay, Jeremy, I get this subnetting thing, which we're going to get into in a moment, but how much do you really use subnetting? I'm talking, you work for a company, how much do you really use subnetting every single day? And honestly, I kind of look at that, I'm like, well, it's really important, but I don't think this is something that you use every day. But, I mean, come on, hang with me. I mean, what do you do every day in a Cisco world in a corporate network? Not much. I mean, unless you're maybe switch stuff, adjusting ports and speeds and all that kind of stuff. But I mean, usually when you set up Cisco routers, they just run and run and run and run. But my answer to that question, I usually say, okay, yes, you won't be doing it unless you work for a service provider. Right? Then you're doing subnetting all the time, every hour of every day. That's what you do in a service provider network, is carve out these networks for your customers. So here we are. Welcome, service provider. We're going to take a look at at this point I would call it the foundations, the keys to IPv4 and IPv6 addressing, just understanding them. And then I would say the most important thing, well, I hate saying that. It's all important. But a very important thing, at the end of this nugget, we're going to get into the flow of network communications and really, I think, couple a lot of the concepts we talked about previously in the OSI model now with the foundations of IP addressing. Well, let's start off with IPv4 addressing. And as I was looking through these 5 bullets, I'm like, man, these 5 bullets on this slide are so rich with information. We may be here for a little while. So IPv4, 1970s time frame, this was released, which is pretty amazing if you think about it, is an address which represents essentially your computer's home or a device's home on a given network. So I'm doing an ipconfig command on this Ethernet adapter, and I see its address is 172.30.100.30. That's its IPv4 address anyway. And I can see that this is made up of 4 octets, each one of these numbers being an octet. It gets that name because if you think of an octagon or octal, it means 8 sides, or an object of 8 sides. So this is actually represented or created by a combination of 8 binary values. So each one of these numbers is 8 binary values. If I take 30, that'd be something like 64, 32, that'd be 16, 8, 4, 2, there we go. I did that in my head, so if I'm wrong, don't quote me, but there's the concept of what it would be. So that's the binary value of the number 30. Now we're going to talk about how to do that in just a moment, but that's where it gets this name octet. I'll talk about IPv6 in just a second. I was going to tangent there, but each one of these values, each one of these numbers is a value from 0 to 255, and that's just the limitations of the binary behind it. Now, this IP address is always combined with a subnet mask and usually a default gateway to really give it meaning. The subnet mask is what tells the division of an address as to what represents the network and what represents the host. Now, before we get into custom subnetting in the binary, I'm going to start off with the 3 core classes of IP addresses: Class A, Class B, and Class C. Class A addresses have the default subnet mask of 255.0.0.0. Class B, 255.255.0.0. And Class C, 255.255, the most popular subnet mask in the world, 255.0. Now, how do you know what class a number, or I should say an IP address, is? It all depends on what number it starts with. If you have an IP address that starts from 1 through 127, it is considered a Class A address. So if you're looking at it, you go, okay, that is, well, I would say in this case, it's not a Class A address. But if that first digit right there, this guy, was 1 through 127, it would be. A Class B address is 128 through 191. The Class C address is if that first digit is 192 through 223. So unfortunately, those are just numbers that you're going to want to slam into memory, so you're able to identify what I would call the default subnet mask for a given class of address. So looking at this, it is a Class B address. So 172.30.100.30 by default, meaning out of the box, if I was following 100% standard-based IP addressing, would have the subnet mask 255.255.0.0. What that would mean is the left half of the IP address, essentially the digits lining up to these 255s, would represent the network that this device is on, and then the right half would represent what host this device is on that network. So he would be host 100.30 on the 172.30 networks, and when I say networks, I'm talking everybody's plugged into the same switch or group of switches right there, and they'll all start with the same 2 octets, 172.30. something, right? Well, the problem with that subnet mask, essentially, by the way, this is called class full subnetting, is using the default subnet mask, is that you have one network with a whole bunch of hosts. As a matter of fact, knowing that each one of these can be a value of 0 to 255 leaves us with a network that has up to 65,535 host addresses that you could use in this environment. Actually, 36, but then anyway, we'll get into the specifics of that. Let's just say a lot. A lot of host addresses that are there. Now, the problem is Cisco recommends, and I'll say this is a soft recommendation based on your network, that you never have a network larger than 500 hosts. The reason why is the broadcast traffic just starts to get unruly. You have computers that are sending broadcasts and broadcast. I mean, it's part of a normal day in the life of a network, and these broadcasts are happening all the time. And the more computers you have in that network environment, the worse and worse the broadcast traffic gets. So much so that it bogs down the whole network. So this slightly exceeds that recommendation of a maximum of 500. Now, I would say 500 is a very loose recommendation in the sense that I usually see networks that usually around 200 to 300 devices, people are saying, okay, let's divide it into another network. So this class full addressing, I mean, the class A is even worse. You get 16 million some addresses on one network. It just doesn't work out, and that's why long ago we went into a class less addressing environment, meaning we still have the default subnet mask that things begin with. However, we can change the subnet mask, as you see right here, to whatever fits our environment. Right here on the screen, we are actually doing subnetting. We are putting a class C subnet mask on a class B address, and that's kind of changing the rules of the game. We've made the network smaller because now you only have about 254 usable host addresses on that network. Now, you might say, well, Jeremy, where are you getting that? Well, in a network environment, you can only use. Let me back up even more. My mind immediately goes to subnetting. So let me say this: the very first and the very last address of a network cannot be used. So when you have 172.30.100. something, this network right here, I cannot use, in this case, 0, nor can I use 255. 0 represents the network and can't be assigned to a device. So when I'm talking about that network, it's like the name of the street that you're on. 172.30.100.0 represents that network. 255 is a broadcast address used to send a message to all the devices on that network. So if I want to give a message to everybody, I would send it to 172.30.100.255. So we only usable have 1 through 254 addresses on that network. Well, let me clear off the scribbles there and come back to my original statement that said this is always combined with a subnet mask and usually a default gateway. Why do I say usually, and what is that default gateway? Well, the subnet mask is what allows the computer to determine what is on and what is off his network. So if I have a computer right here and it's connected to a switch, it has the address 172.30.100.30 with that class C subnet mask that we have right there. I'll just draw it right there. It knows that it can reach any host that has 172.30.100. So hang on, let me unpack that. Let me define that. It knows that it can reach. So the big question says, well, how can it reach? I know that sounds like a really basic question, but I mean, really, how does it happen? So let's just say there's another computer on this network, 172.30.100.50. And you open a command prompt on this computer and you type in ping and type in this IP address. What's it do? Well, it immediately realizes, it goes, oh, wait a sec, 172.30.100, that's on my